Hello there, this is my latest build. It's an attenuator, a step attenuator. I've built this out of a faulty Tektronix 491 spectrum analyzer, and it's this part here from the other analyzer, the faulty one, and this worked perfectly fine. And what I did is I put a nice die cast enclosure, very heavy and very solid, and two nice unfennel connectors here, Teflon connectors, nickel plated with gold plated inserts, and I just mounted it here. It fits perfectly, and I also used the spare panel from the other from the spectrum analyzer to have these nice markings here for the attenuation values. It's this panel here, so I cut this panel here from the spare one I had, and I used it this attenuator. From the bottom side, I haven't mounted the screws yet, the 4 screws that hold the enclosure together. There is a one of these soft how to call this soft things that you put under the furniture to in order not the furniture not to scratch the floor. Okay, because I didn't want to have this scratched. It's a very nice painted enclosure, and I didn't know to cause scratches onto the desk, so it's nice and easy. And let's see the attenuator inside. It's really interesting. Here we go. This is the attenuator. We're talking about Tektronix quality here. It just fits this nice enclosure, and the connections here. Let me focus a little bit. The connections here at the plugs are done with a bit of solder. It fits nicely, and notice how well the resistors, the 5% carbon composite resistors, have been soldered by the Tektronix engineers. And by the way, those switches used on those attenuators are of extreme quality, very nice and dependable switches. So yeah, this is how it turned out. I'm pretty happy. Not so much to say about this video. I'm gonna test the performance of this attenuator, and it's going to be used with the type 190B constant amplitude signal generator, the modified generator I have here, in order to reduce the amplitude by 51 decibels, so it will have more appropriate output level for the RF experiments. So yeah, overall very good build quality. This thing weighs about about half a kilogram now. Very nice build quality, and I'm gonna test it. This attenuator worked in the original spectrum analyzer in the 75 megahertz IF. That's why it has also the IF attenuator here, and I'm pretty sure that it will work fine up to 50 megahertz here, which is the maximum frequency of this signal generator. So I'm gonna do some measurements and see how it goes. But I wanted to present you the overall build quality and constructions here. I hope you enjoyed it, and thanks for watching. Now, I've checked this attenuator, and it turns out that it cannot output the correct values here. I have checked it with the Tektronix 190B. I know that this is calibrated. I have calibrated myself and checked it against this scope, and I have checked this scope against a modern scope, and the voltage, the peak-to-peak voltage is match. In order to calibrate it, I matched the peak-to-peak voltages with the calibration procedure, and it's calibrated. So both the generator and the oscilloscope is calibrated, and I have checked the output readings based on the different attenuation values of this attenuator, and they don't match. So I assumed that either this is not a 50 ohm attenuator, so what's inside the Tektronix 491 spectrum analyzer in the IF, it's not a 50 ohm attenuator, or that the resistors here have been drifted in value over the years. So I've checked the resistors, and they seem to be all drifted in value. And notice from the schematic of the attenuator that let's remove the glare a bit. Notice that these resistors are pretty standard, and if you place the multimeter at this point, for example, and try to measure the 240 ohms resistor, you have to also take into account, without this attenuator to be switched on, okay, like it is shown here in the diagram. So you have actually three resistors there. You have from this point to this point, you have this resistor, the 240 ohms, and you have a resistor, this resistor in series through the ground with this resistor, and both of these resistors are in parallel to this resistor. So I have calculated the total resistance that I should read when I put the multimeter at this point here, or at this, 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 and almost, not almost, all the resistors, all the resistance values seems way off. And this might be why I'm getting erroneous readings on this attenuator here. Thankfully, these resistors are of pretty standard value. They're not some decimal point resistors. 62 ohms, they can be made, or you can order 1% or lower resistors, I think. 60 ohms, 240, 150, 68, 51, 120, 24, 220, 12, 430, 5.6, 910 and 10 ohms. So I think I could be able to find those resistors, those precision resistors, and remove the old ones, and solder this, and fix this attenuator. Okay, so but first I have to do a final thing here. I think I'm gonna lift one of the ends of these resistors, the series resistors, and check at least the series resistors to verify that they have been gone bad, and not affected. The reading that I'm getting is not affected by the other two resistors connected to the ground on its pad, on its attenuator pad. So yeah, if it turns out that this is the case, that will be really bad also for my other Tektronix 491 spectrum analyzer, because obviously those resistors inside this attenuator would have been drifted too, and it would be not a very good thing to have a non-calibrated attenuator there. Thankfully I have I'm using the comparison method to do the measurement, so I'm always feeding a reference signal generator to this spectrum analyzer, and compare it against the signal that I want to measure, and use the signal generator as a marker, in other words, and do the measurements. So I don't care too much if the attenuator here is calibrated. It would be nice, but at least it would be a very nice lesson to find out just how badly these carbon composite resistors can drift over the years. I know that they drift. I know that they drift a lot sometimes, but this seems way off in some of these resistors, so I have to check this out. Leave the resistors and find out if they indeed have drifted off. So here we go. I have lifted those resistors. I have lifted those resistor, this one, this one, this one, and this one. And these resistors are basically one of the... I have lifted, for example, this resistor here, and if I lift this end, then I can measure this resistor alone and this resistor alone at those ends, and this resistor alone from this end to the ground. So by just lifting one of the resistors, I can measure all three resistances here without one affecting the other. So this is what I have actually done here. And guess what? These resistors are way off. I mean, way off, guys. All of them have badly drifted from their original value, and I have verified that the values of the resistors, the colors of the resistors, are the values that are shown in the schematic. But when I measure them, they have all badly drifted. One or the other direction. I have found some resistors that measure way high, and some others that measure way low. So whatever this attenuator input and output impedances or pad attenuator values were originally, have been gone way off now, and it's not usable at all as it is. Now I'll have to replace 18 resistors. I have to replace 18 resistors, all the resistors of this attenuator, in order to make this usable again. And hopefully it is a 50 ohms attenuator. So we are going to I'm going to build this again, to rebuild this again into specs. And thankfully today we do have precision resistors, and I can find 18 resistors are not much of the cost. And I really like this attenuator, how it turned out. It's a really small for a switched attenuator, really small, and it's very solid the way it turned out. So I think it does it worth it. It has some very high quality, of course, switches, and very nice good quality enclosure and high quality connectors. So the only things that need to be replaced are those resistors, so I can rebuild again this attenuator to the original specs. And no wonder why I saw so much difference from what was expected. The resistors are badly drifted. So that was a good lesson. I'll try to replace those resistors and see how it goes. So the last thing I wanted to do is before I order these resistors, was to check if this attenuator is actually 50 ohms attenuator, because I can't understand from the schematic of the 491 spectrum analyzer if this is really a 50 ohms attenuator. It doesn't have any connector inside the schematic. It's connected internally to the circuits, and it's not really obvious if it is. So what I did was I found a calculator